Welcome to this explainer. Today, we're going to dive into a phenomenon that absolutely every single one of us has experienced, and usually, right when we're in a massive rush. You sit down at your desk, you fire up your computer, and you just wait. And you wait some more. A machine that used to be lightning fast when you first took it out of the box is now inexplicably crawling. It's a completely universal frustration, right? Well, today, we are looking at the actual source material behind this technological mystery, and I promise you, the answer is way more fascinating and honestly a lot more physical than you might expect. So, ask yourself, when your computer starts behaving like it's walking through wet cement, what do you normally blame? If you're like most people, your mind instantly goes to the digital realm. You probably think about a virus you might have accidentally downloaded, or maybe you've got way too many tabs open, we've all been there. Or you assume your hard drive is just getting entirely too cluttered with old files. We've been trained to think of our computers as these pristine, invincible calculating machines that only fail when the invisible code inside them gets messy. But what if the problem isn't just digital? What if it's intensely physical?
See, we've all been conditioned to point our fingers at bloated software and those endless, annoying updates, assuming lines of code are just piling up and choking the system. But we rarely consider the shocking reality of the situation, which is physical hardware wear. We don't really expect the actual physical pieces of a microchip to just wear down from use, like the tires on a car or the soles of your favorite running shoes. We've totally separated the software from the hardware in our minds, kind of just assuming the hardware is this immortal container. Yet, understanding that this physical deterioration is actually happening inside our machines is exactly what we need to start wrapping our heads around.
And this brings us to a really crucial point, captured perfectly in the research. It's not just Windows updates. Your processor is physically wearing out. For me, this was a massive aha moment. It completely shifts our mental model away from purely software-based issues. I mean, yes, software can absolutely be bloated and updates can be super heavy. But underneath all of that software, the physical engine of your computer, the processor itself, is fundamentally experiencing fatigue. It's literally aging. The hardware is undergoing a physical transformation just by doing its job day in and day out.
This introduces what the source text calls a hauntingly accurate concept, the ghost in your CPU. I absolutely love this biological framing because it takes these cold, hard, seemingly immortal squares of circuitry and makes them feel alive. It makes them feel mortal. When we talk about a ghost in the machine here, we aren't talking about some random glitch in the software. We're talking about the inevitable, creeping mortality of the hardware itself. Your CPU is susceptible to aging, just like absolutely any other physical object in the universe.
To truly understand this ghost, we gotta go on a bit of a fantastic voyage. We need to shrink our perspective way down from the macro level of your desktop monitor and zoom deep into the hardware. First, we're looking at the silicon wafers. This is the foundational bedrock of your hardware. Then, we go deeper into what the source beautifully calls the CPU DNA. This is the fundamental, microscopic architecture that makes your specific processor what it is. And finally, we get down to the microscopic transistors. These are the billions, literally billions of tiny physical switches that are flipping on and off at blistering speeds just to process your every command. It's down here, at this unimaginably small scale, where the physical wear and tear is actually taking place.
And that brings us to the scientific climax of our explainer, electron migration. So what is that? Well, it's the physical wear and tear on those microscopic transistors that causes the hardware to fundamentally age. Think of it like water slowly eroding a canyon over time. Because those transistors are so incredibly microscopic, the constant rushing flow of electricity through them actually takes a physical toll. Over time, the sheer force of electrons moving through the CPU's DNA essentially degrades the pathways. It is literal, physical wear and tear happening on a scale that we can't even see with the naked eye, fundamentally causing the hardware to age and lose its original out-of-the-box efficiency.
So let's connect the dots here and look at the exact life cycle. It all starts with constant electronic usage. I mean, every single video you stream, every email you type, it keeps electricity flowing. That constant flow physically degrades the silicon pathways via that electron migration we just talked about. The actual atomic structure is shifting. And the result? Your processor has to work harder and less efficiently to accomplish the exact same tasks, which you experience on your end as a frustratingly sluggish PC. Actually, it's not a mystery at all, it's just a direct, physical chain reaction.
Which leaves us with this lingering, provocative thought to wrap up our explainer today. When will the ghost in your CPU appear?
Because every machine has a lifespan, and it's dictated not just by the random software you install, but by the physical mortality of its own microscopic transistors. So the next time you're staring at a loading screen, drumming your fingers on the desk, remember what's happening deep down in the CPU DNA. It might not be a bloated update at all. It might just be the ghost of electron migration, reminding you that even our most advanced hardware is wonderfully, frustratingly mortal. Thanks so much for joining me for this explainer, and I really hope this new perspective leaves you as fascinated by your own machine as I am.